Hello, everybody. My name is Mike Human. I'm with G2M Research, and this is our webinar on NVMe over Fabric adapters. Quick introduction here. I'll go through everybody and introduce the panelists. After that, we'll have Howard Marks, who will be emceeing the event. We'll talk a little bit about NVMe over Fabrics and why that's important. Then we have 4 questions we'll ask the panelists. We also have 2 survey questions that we'll be asking you as the audience. And you can just respond on your screen, and then we'll be able to show the results. After that, we'll have a little Q&A session for about 10 minutes, and I'll do closing remarks. Should finish about 10:15 or so. So with us, we have from Mellanox, Rob Davis, who's VP of Storage Technology, and John Kim, who's Director of Storage Marketing. From Broadcom, we have Elliot Rosen and Frankie Fan. Elliot is the Product Marketing Director. Frankie is the Systems Architect. Tawfiq Ma will be joining us from Atala Systems. He's the CEO there. Brian Calger, who's the VP of Sales and Marketing at Kazan Networks, has also joined us, along with Ahmed Hussain, who's VP of Marketing at Solar Flare Communications, and Praveen Mehta from Cavium. And with that, Howard, I'm going to turn it over to you.
Very good. So NVMe is a new protocol for non-volatile memory access. SSDs that we've used to date, whether they were connected to physical interfaces that came from disk drives like SAS and SATA, or connected to the PCIe bus, were still accessed either through the software interfaces that came up with SAS and SATA. So the first generation of PCIe SSDs frequently had ACHI, the SATA command set interfaces. Or vendors like Fusion.io and Virident created proprietary interfaces that had a heavy software footprint. The advantage of NVMe is because it's specifically for talking to non-volatile memory. And of course, non-volatile memory today means primarily flash, but 3D XPoint and a whole raft of other next generation memories are coming. Because NVMe is specifically designed to talk to flash or to other non-volatile memory and not to the universal set of peripherals that SCSI was originally designed for, it's a much cleaner software interface. There are much fewer CPU cycles involved in getting a block of data into and out of an NVMe SSD than a SAS or SATA SSD. It's also much more massively parallel. A hard drive can only read or write from one head at a time, and therefore SCSI only anticipated having one queue with 64 entries or 32 entries accessing that device. An NVMe device can have 64,000 queues of 64,000 or 64K in binary actually, so 65,384 queues of 64K entries. And that means that in an environment like a disk array or other shared storage environment, many applications can be accessing the same SSD at the same time. And so what that gives us is a substantially narrowed piece of delay or latency. Today's NVMe SSDs typically deliver data somewhere in the 10 to 15 microsecond range, which is enormously faster than the ACHI interface. Plus, we have the additional parallelism. Next. So the problem with NVMe is that NVMe is almost exclusively a PCIe software interface. The hardware interface is still that bus in the server. And that means that all the storage is local. We have, over the past 20 years, designed our data centers around the concept of shared storage. And NVMe over Fabrics extends and encapsulates the NVMe semantics, that is, that software API, over a fabric network of some sort. You can think of it as conceptually similar to iSCSI, which encapsulates the SCSI command set within TCP/IP. But because NVMe over Fabrics was designed in today's low latency environment, not in a much higher latency environment of the hard drive 20 years ago, rather than sending data across 1 gigabit Ethernet, today's NVMe over Fabrics solutions use today's low latency network environments. And today that can mean, in the drafts available today and the adopted versions of the standards, that can mean Ethernet with RDMA and either flavor of RDMA, RoCE, RDMA over converged Ethernet, which requires the Ethernet extensions that were designed primarily to support fiber channel over Ethernet, or iWarp, the RDMA over TCP protocol. It can also run over fiber channel, and so storage administrators who insist on having a dedicated storage fabric that the network guys don't get to play with can continue to use the fiber channel they know and love. It runs over InfiniBand, which is the original RDMA network, and much of RoCE is simply porting InfiniBand semantics to Ethernet. And there are versions of NVMe over Fabrics for TCP/IP in draft. While that may add a tiny bit of latency by comparison to the RDMA solutions, it may also simplify setup. NVMe over Fabrics today adds namespaces and discovery, some of the services necessary for running what we traditionally have called a SAN, but new generation vendors will, of course, object to that term. The basic takeaway is that NVMe over Fabric adds somewhere in the 10 to 50 and more likely in the 10 to 20 microsecond range from the compute server to the NVMe over Fabric array and back. And that's almost more than an order of magnitude faster than the SCSI alternative protocols. And that means that we can now have shared NVMe SSDs take advantage of all of the HA and application mobility advantages of shared storage while still having the ultra low latency that NVMe delivers. NVMe over Fabrics is being spread and adopted much faster than the last new storage protocol, iSCSI. It took 3 to 4 years for us to get from the iSCSI specification finalization to the first iSCSI products that were worth having, the EqualLogic and Left Hand as my examples. It's now about 18 months since the first NVMe over Fabric specifications, and we're now seeing mainline storage array vendors announce support for NVMe over Fabrics in their products, both as a compute layer access protocol and as an array to expansion storage, kind of the shelf protocol. In my opinion, over the next 4 or 5 years, NVMe over Fabrics will essentially replace SCSI as the lingua franca for high performance storage communications. You know, the best example of how fast NVMe is moving is that the simple existence of NVMe led the folks at Dell EMC to look at their DSSD project, which built a ultra low latency shared storage system using proprietary switched PCIe hardware, and to decide that the benefits of that solution were not worth the additional cost that was necessary from having the proprietary hardware. So they killed that project off.
Excellent. So with that, we're going to start the panelist questions. We've changed the order of each question, or the response orders. So on the first question, Mellanox will go first, followed in the order shown here. Howard, I'll let you ask the question.
Sure. So, the first question is, where is NVMe over Fabrics being deployed today? It is a new technology, and it's always nice to see who the pioneers are. I do have an arrow removal kit should they need it. So, Rob, why don't you, where's Mellanox seeing NVMe over Fabrics deployed today?
Thanks, Howard, and also thanks to G2M for the opportunity to be on this webinar. Howard, one small correction. RDMA over Ethernet, or RoCE, no longer requires to have the FCOE parts installed in the network, so you can do it now without Ethernet extensions.
So it's not converged Ethernet; it's just regular Ethernet. Cool.
Yeah, it'll work on regular Ethernet now, depending on the implementation. So I don't want to take away time from my question answers, but where we see it is in 6 different areas. The first is actually one you mentioned, which is, you called it the expansion shelf protocol. And what we call it is back-end storage fabric. So we see it replacing SAS and other technologies and protocols on the network that's behind the front-end storage subsystems or appliances. Pure would be a public example of an implementation like that that's using our ConnectX-4 technology with 50 gigabit Ethernet. WIC-IO also uses our adapters and switches in that kind of a solution, and they're using the NVMe over Fabrics to scale out their file system capacity with basically a shelf expansion behind their filers. These are just 2 examples I can make public, but there are many others, both public and not yet. The second use case we see is compute storage disaggregation. Because, as you said, Howard, the difference in performance between the local NVMe SSDs and the remote or SSDs across the network is so small in all areas, whether it was a latency that you showed, and we've seen latency down, below 10 microseconds in many situations, but also in IOPS and bandwidth. There's really, very little measurable difference in the performance, whether you're running the application local or remote. And what this allows to happen is that you can take applications that are meant to run locally and connect them remotely. So basically disconnecting the storage and the compute, which is super important to the large-scale hyperscalers, because now they don't have to tie their applications to the platforms. So at Flash Memory Summit this year, eBay talked about this with our CTO in a keynote. The third use case is what we call classic SANs. Basically replacing, classic fiber channel SANs with NVMe over Fabric. So Pavilion would be a partner of ours that's in that use case. I don't think I need to describe it, since it's, predominantly a storage crowd familiar with SANs here.
Well, and you are out of time.
Okay.
So we'll have to move on to our next participant, because I know we could go all day. So what's the Cavium view on where things are being deployed today?
Hi, good morning, everybody. This is Praveen Mehta. I'm with Cavium, QLogic. So yeah, before we look at where NVMe or Fabrics are being deployed, let's take a quick look at the state of the union. The RDMA spec was out in June of 16, and NVMe got ratified in August of 17. So there's a huge momentum from a standards perspective. Storage array vendors, AFA, FBOF, SSAs, JBOF, SDS vendors, they're all evaluating these technologies and measuring, right? Trying to make sure there is an appropriate fit here. And enterprise customers are really wanting to make sure that this technology is ready for prime time. I think it's very important to highlight that there's a fair amount of software stack hardening that's in progress, because storage customers expect parity or improvement over existing transport capabilities, be it use, configuration, deployment, and recovery. So in terms of deployment, on the target side, we are engaged actively with both FC and RDMA. There's several projects we are engaged in at the POC level. We are talking to several tier 1 server and storage OEMs that are targeting to bring FC and VME into the marketplace Q1 of 18. And I think on the host initiator side, the ecosystem is pretty much built out for RDMA, and it's starting to build out for fiber channel. So like I said, we are expecting announcements the first half or Q1 of 18 on SC and UAE as well. So overall, there's huge momentum. I think there's a significant amount of POC activity that's in place right now that we are hoping to bring announcements around starting early next year.
Very good. Thank you. Matt, how are things at SolarFlare with NVMe over fabrics? You guys are taking a slightly different take on it, aren't you?
Yes, we are. So thanks again for G2M, and appreciate the time to talk about this. I somewhat agree in the use cases that have been described as, standard array systems with back-end fabrics that used to be SAT, fiber channel being replaced with NVMe. Also the front end of those storage arrays going towards NVMe class connections. We see that in the market space. The second area, which I think is the most pertinent and the one that it seems to be tracking from our engagement with our customers, is the disaggregated storage environment, where storage can be anywhere and any node can access that storage at the performance level that it was locally connected. So I think that's a very interesting deployment we're seeing. We've seen several big customers of ours starting to play around in that space as main deployment. In fact, I can tell you about one specific customer who's engaged with is deploying diskless across structure, but they want the flash essential SSDs to be in one place instead of it technology to really take place. So we aggregate the area and see the most to apply on data structure. Okay. So, and we think it's all based on Ethernet, nothing else. Hopefully that. Howard, I can't hear you speak. Sorry.
Thank you, Emmett. Elliot, Broadcom's strong in the Ethernet space. Would you agree with that? That the future is going Ethernet?
We would. Yeah, that is our belief, at least from my business unit, because we are an Ethernet-based business unit, is that a predominant amount of the deployment will be in Ethernet. But Broadcom also does support fiber channel, and so we have solutions for that market as well. From my perspective, this has actually been a pretty exciting year. There's been a lot of activity, just in general, a lot of product introductions from components to system levels after a lot of years of talk. So I agree with the previous panelists that the level of activity and excitement is pretty high, and that's all good. The way I like to break things down is kind of into two buckets, so to speak, and I'll put the first one into maybe the OEM enterprise bucket. And at this point, what we're seeing is that every OEM is either in development or planning of some type of NVMe over Fabric solution today. So that's a big change from just a year ago. In enterprise environments, what we're seeing is NVMe over Fabric being implemented initially as kind of a back-end expansion, especially for like smaller enterprises who want to add flash for existing high-performance applications, to more disaggregated storage models in private cloud architectures. So these are kind of two applications, and typically in enterprise, you're going to see HA-based types of architectures and attributes. We also believe enterprise customers will take a little bit longer to adopt RDMA on the host side of the network. And most of that has been just due to limitation on hardware, software availability. And so, but we see that eventually moving into the mainstream. But initially, the deployments we're seeing are on the back end. And then the second bucket I like to look at is more from a cloud perspective. And from our viewpoint, this is the one that offers more deploying opportunities. Operators are looking to capitalize on the scalability and flexibility of hardware and software topologies, and increasingly there's more powerful applications and distributed workloads. So that lends itself directly to a disaggregation model where scaling your compute and storage separately kind of falls really naturally into the benefits of NVMe and NVMe over Fabrics. It also helps solve a number of issues impacting their ROI, both CapEx and OpEx. You know, as an example, some cloud operators have said 40% of their NVMe in storage servers today is stranded or siloed. So being able to disaggregate that has direct CapEx impacts. And so
Yeah, well,
also
that's the shared storage story all over again.
Yes. And so, you know, the rapid change is also an earmark of kind of cloud deployments. We're seeing a lot of feature velocity, and that's also an important factor as the cloud operators really decide on how to allocate each of their compute storage pools. So
Thanks,
you know,
Elliot.
we're seeing a lot of POCs and all great activity.
Great. Tawfiq, how are things, what's going on at Attila in terms of current deployments?
I think we might be having technical problems with Tawfiq getting on. Why don't we go to Kazan
Okay,
and see if we
we'll
can...
move on to Brian at Kazan.
Sure. Yeah. Thanks, Howard. And again, thanks, Mike, for putting this together. So, yeah, general agreement with everything that's been said. Kind of two main buckets for us. Second, platform, enterprise storage, replacement for both the SAN based on Fiber Channel or iSCSI, and replacing SAS as the back end. Get SCSI out of all those connections as a protocol and replacing it with the superior NVMe. And then the second bucket, a larger and faster growing market, is the third platform space. As others have mentioned, get past today's shared nothing model, separate out the compute and storage, share pools of storage much more efficiently. NVMe over Fabric's really ideal for that. So for cloud installations, it's a clear winner and a clear TCO savings play.
Yeah, none of you guys used the magic word composable, but I think that's a key advantage of NVMe over Fabrics is having that storage out on the net means that we can allocate it to workloads much more dynamically than we could disk drives that were locked behind other devices. All right.
I think we just have different names for it.
Yes, exactly. But I'm an analyst, and that means I get to make up my own taxonomy.
One of the benefits of being an analyst.
Oh yeah, it's one of our main jobs is making up words for things. I mean, you guys have all, several of you have used the Gartner model. It's third platform. It's like, yeah, cloud stuff. All right, so audience members, please let us know. What are your plans to deploy NVMe over Fabrics? You've already deployed NVMe over Fabrics. You're a pioneer, and I would like to rent you my patented arrow removal kit. You plan on deploying NVMe over Fabrics next year or in the next 3 years. You plan on deploying NVMe over Fabrics after 2020, after somebody else has found all the problems. You currently don't plan to install NVMe over Fabrics over the next 5 years, or you haven't figured it out yet. Personally, I suggest that not having figured it out yet is probably the most reasonable choice for those who aren't planning on installing next year. As we wait for our audience to join, the next question on our agenda is about the factors preventing or enabling deployment of NVMe over Fabrics as a replacement for existing storage protocols. Now, I have my own opinions, and we'll see if we come up with those reasons from our panelists. So since we've had some trouble getting hold of Tawfiq, he's not with us, right? Then we'll just have to let Elliot kick this one off.
Sure. Thanks, Howard. Actually, it's a really good question. And as in any of these evolving markets, there's always a number of variables. In the end, I kind of look at it as three drivers, and it's really regardless of what part of the storage market, be it enterprise or cloud, that you're talking about. So one, it comes down to what problems you're trying to solve, and one of the things the attraction of NVMe has is, from the onset, was it's based on high performance. The other is TCO to the operators or end users who are implementing these solutions. And then the last one is actual availability. When we look at things like, comparing this to existing protocols like SCSI command set that are implemented over different networks, whether it's iSCSI or iServe or Ethernet and IP or Fiber Channel or InfiniBand SRP or even SAS or Direct Connect, as well as even things like NFS and Object. Kind of the main thing I see from NVMe protocol standpoint is that it's really a block storage that's today or yesterday being implemented over PCIe and now evolving to fabrics for scalability. And so all have their place in storage market, but really see NVMe as having the right kind of aspects of performance, and as costs get better with flash, that this extension to users will make it more of a replacement as we move forward. So if I kind of look at some of the pieces here and some of the evolving kind of dynamics in the market, I'm personally from the Ethernet business unit, so I kind of look at iSCSI as being one of the deployments, and I think Howard, you kind of mentioned this before, and I look at it as kind of the lowest hanging fruit for the performance-driven applications in iSCSI. If you look at some of the more dedicated type of networks like Fiber Channel, that's a bit more challenging, mostly due to the conservative nature of a lot of that customer base, especially being large financial institutions, et cetera. But the demands are there, and even on our Fiber Channel side, we're seeing that a number of the customers in that business unit is servicing are looking at NVMe over Fiber Channel, for instance. But one of the interesting dynamics that we're seeing, even with the Fiber Channel guys, is that as they start looking in the future to 100 gig and 200 gig, they are saying that Ethernet is becoming more of a possibility for them. So we do see over time more of the market moving towards Ethernet and even replacing things like Fiber Channel. So kind of this year is the year 20. Oh, go ahead.
So Bob Metcalf was right when he said he doesn't know what network we'll be using in the future, but it'll be called Ethernet.
Well, it depends on your perspective, but
yeah,
we certainly see Ethernet as a strong area of where Fabrics is going to be deployed, and
okay.
We're seeing a lot of the deployments today.
Great. So I see that Tawfiq is back on the line. So since you were supposed to lead this one off, why don't you take that now?
Okay, can you hear me okay?
Yep, we got you.
Okay, thanks, Howard. Yeah, so this is Tawfiq from Atala Systems. So as a shameless plug, we have a solution today that we're shipping to customers, and you can find out more at atalasystems.com.
Okay, you've used your shameless plug period.
But to the specific question, so I think the biggest impediment when we engage with end customers is it's the evolving use models. The beauty of NVMe over Fabrics is you can do many different things with it. So Howard used the term composable. So at its base functionality, you can compose NVMe block storage for a variety of different applications. But when we engage with customers, they're looking for the specific use models. So more recently, we've been focused on creating solutions to address some of these impediments for adoption in terms of solutions built out using Lustre, HDFS, GPFS, and other data lake layers. So that's in summary, that's sort of one of the things that is preventing broader adoption is sort of the evolving use model and how customers see the technology being used to solve their real world problems.
Well, I mean, that's true of most technologies. It takes us a while to absorb things. I mean, from my perspective, Flash has taken a decade and we've just gotten it. And now we're in wave 2 of figuring it out. Brian, what's your take on this?
Well, I'll jump in with a shameless plug as well. We've been shipping our prototypes out to the market for over a year now, so it's certainly available for folks to start testing. And in terms of enthusiasm and interest level, I can't imagine it could possibly be any higher. I'm not aware of any major web player or storage vendor who's not actually playing around with hardware at this point and either determining a strategy or, as we've already talked about, some have a strategy and are running with it. So those are all the positives. In terms of factors preventing or slowing things down, I would point to a couple at this point. I think we still want to see a little bit more maturity happening on the driver side. Obviously, a lot of work that has gone on and is still ongoing for the Linux NVMe over Fabrics driver. And, we're still seeing some challenges each time the kernel rolls, subtle little differences that are changing, but that's, I think, to be expected for a new protocol and a new ecosystem like this. And of course, we're confident that that will be fixed over time. And then on the hardware side, I think I think the market's waiting for production level silicon solutions, which I think is, all kind of lining up for next year. The prototypes out there now appear to be either based on FPGAs or early production versions of silicon. And so I think there's going to be a lot of hardware stability and availability coming out next year that will really kickstart things.
Okay, Rob, what's holding NVMe back, or what's pushing it forward from Mellanox's perspective?
So my plug isn't going to be shameless. We've had our products both in InfiniBand and Ethernet switches and adapters in the NVMe product space, shipping to customers who are shipping to their customers for revenue for over a year. So I think what we see as enabling on the enabling side was mentioned earlier, which is performance, but it's not only the wire speed. There's new wire speeds that you mentioned of Ethernet all the way up to 100 gig. We'll be shipping 200 gig later this year. And that's certainly driving it because the flash demands a higher performance. We like to say, faster storage requires faster networks. But the other side of it is the protocol. And the NVMe over Fabrics protocol, as Howard mentioned in the beginning, is so efficient that it's just enabling all these new application spaces. And then the other side is the cost. Because it's PCI based and you eliminate those extra controllers for SAS SATA or fiber channel or whatever you're putting on the back end, you're reducing the cost of your storage implementation of the base technology, which is NVMe. And so the overall cost is dropping as the performance is going up, and the performance is also the cost is also being driven by the switch from Ethernet to, from away from higher cost fabric solutions, for example, fiber channel.
I like the way you said that, fiber channel.
Well, I was CDO at QLogic for 15 years, so I know a little bit about it. So on the enabling side, we have already occurring the UNH plug fests, which prove interoperability between vendors. So we've participated in both of the first two, and there's another one coming up this spring. And we've shown wire speed at 25 gig with multiple vendors at both initiator and target side. So I think that goes a long way towards enabling it. And then the hype factor somebody mentioned earlier. On the prevention side, I agree with the slow movement of the storage industry. It's very slow to adopt new technologies. And then there's some immaturity in the standard. An example there would be holes around multipathing and the automation and discovery that are being plugged by the solution providers now. But having that standard would allow mixed environments of vendors and OSs and things like that. And then completing the OS coverage would be my last one. So we have Linux today, and Red Hat is either already or soon supporting it in their Rails. But when we have projects underway for Windows and VMware, and you can get them, kludge kind of things, but those will be
storage
coming out
guys are
this
conservative.
year.
They're not going to run kludges.
Yeah, but you're going to see both the Windows and the VMware being, more mainstream coming up later this year.
Thanks, Rob. Ahmet, what's the solar flare view?
Solar flare view is that we see there's two classes of market space that we look at, and we look at from an end user perspective. There is a transition in the industry, as we all been discussing for many years, away from this traditional three-tiered compute model in your data center to a more disaggregated infrastructure of scale-out environments. In those environments, we think one of the biggest preventions that is a barrier is putting something that is not standard Ethernet on top of that. And that is, we think, one of the barriers, because the industry is moving away from fiber channel and SANs into more of the disaggregated distributed environments of scale out. And we believe making NVMe usable in that environment as just as simple as a plug-in that gets loaded into your operating system, whether it's Linux or Windows, that enables NVMe over Fabrics to work is where we think is the biggest barrier. And we have met many customers, direct end users, who are in the transition of scale-out data centers, but are not looking to implement SANs. And so they're looking for this kind of solution to enable them to use disaggregated storage. So we think this is where the real play is, and enabling that simple as possible, i.e. when you have a server that you turn on that has the plug-in, every flash storage device that's connected on NVMe is discoverable and usable. I think that's our nirvana, and that's what we're trying to enable in the market space. We think that's the biggest barrier of entry. And we've come across multiple customers that have articulated that problem, that they want to have a pure Ethernet network and they want to be able to utilize this protocol on top of that, as simply as plug and play.
Thank you. You know,
And I won't do my shameless plug. We do have a TCP version that's in customers' hand and being tested now. So that's my shameless plug.
Okay, so everybody's had their shameless plug now. From where I sit, you know, the enablement is kind of obvious. The spread is really quick, and everybody loves low latency. But it is that protocol maturity that I think is a limitation on the enterprise side. You know, we like our multipath. You know, you call storage guys conservative, and it's no understatement. So,
Howard, I think we missed Praveen on the last question. So.
Oh, Praveen, so sorry.
All right. I think I actually agree with a lot of the comments that have been made, but from our perspective, I think some of the key enablers are really around low latency in terms of fabric, media, and I think the standards has to be a standards-based solution to make it truly interoperable. So I think it's important to highlight that 96% of the world's banks, airlines, retail run over fiber channel, and over 30 billion transactions are going through FC every day. So, and they would love to be able to add low latency workloads into these existing SANs with FC and VME. FC is moving to 64 gig, and it continues to be a network of choice for mission critical workloads. And as a shameless plug, Cavium's currently shipping hardware will support both RDMA and FC and VME and TCP in the future. I think one of the critical success factors is that there has to be concurrency of storage transports. So FCP, FC and VME, as well as iSCSI with NVMe or Fabrics on the Ethernet side, so that customers can seamlessly upgrade and add mixed workloads.
I think that's a very good point. That, you know, especially in today's virtualized environment, to say that this host can only talk this protocol to that storage array, but not to the storage array we've been running via iSCSI would be a drawback.
Right. And I think in terms of what's preventing, I would agree. More hardened stack, NPIO, discovery, second level error recovery, RDMA commit operations for writes, and you know the whole ecosystem build out needs to happen, which is happening. So it's not a prevent, but it's just taking some time.
All right, thank you. And moving along to our third question, what do you think will be the primary applications that utilize NVMe over Fabrics? And when do you when do you expect that we'll see widespread deployment? Which of course means we have to define widespread deployment. And I would guess that's kind of 20% of purchases in this kind of application. You know, we're not looking for when it goes mainstream, but when it becomes acceptable to the mainstream. Brian, you get to go first this time.
Oh, great. So, yeah, so we see two general applications of where this is going. I think we've all kind of touched on this already. You know, the biggest and most ready application for this is the third platform, the hyperscale and cloud environments, where this idea of a composable infrastructure really represents a revolutionary breakthrough for them. There's tremendous cost savings to be had, probably the lowest hanging fruit left to optimize these big web scale deployments is this idea of composable infrastructure. So I think people are coming to the realization that the one-size-fits-all sort of compute and storage configuration, what we call a shared nothing model today, is just not working as efficiently as it can be and as it should be. I think, you know, complicating that is the increasing number of applications running in increasingly fewer data centers, more consolidated data centers, increases the workloads that they have to be able to adapt to. And this is exactly the kind of environment that's going to benefit tremendously from composable infrastructure. You know, the specific benefit is significant increases in storage utilization. The next generation data center architecture needs to better comprehend that ever-changing requirement of compute and storage ratios. It just does not make sense to pick a fixed compute storage ratio and have to live with that for the life of that data center. So the TCO savings of a cloud-focused data center are just going to be dramatically reduced by allowing you to tie the precise amount of storage that you need to each application. And if that changes next month, next week, in the next hour, it's just, you know, infrastructure by code, and you quickly rearrange things and reallocate storage to various applications as you need to. And then the second platform, enterprise storage space, we've already talked about the huge benefits of just getting SCSI out of the mix, you know, whether you're talking iSCSI or fiber channel as a connectivity protocol, or the SCSI and a SAS backend and the limitations associated with that in terms of scalability and distance, all ready applications for this. So we really see, you know, 2017, this has been the year of prototypes and development. Production will start ramping next year in terms of real systems that you can buy and deploy readily. I think that in the 2019 timeframe, we're going to start to see the first large-scale production deployments, and by that I mean, you know, entire data centers built around this. And then 2020 and beyond, certainly wide-scale adoption and deployment and general elimination of SCSI protocols.
Thanks, Brian. Praveen?
Sure. So I think at a very high level, let's all agree that NVMe over Fabrics is the next generation enterprise storage fabric. So today's enterprise applications that could benefit from lower end-to-end latency, including databases, data warehousing, data mining are obvious candidates. And I think a lot of the existing apps will probably have to get optimized. Expose them, you know, some of the inherent design inefficiencies that they were hiding behind. So I think some of that work will have to happen in parallel. But in terms of timelines for wider deployment, I think RDMA will continue to lead over FC in the short term because you know, the spec's been out a little over a year longer than fiber channel. RDMA may find initial traction as IP replacement on the backend storage fabric as target vendors continue to refresh their architectures for next generation AFAs and FBOS. And we think FC and NVMe already host solutions will start rolling out in early calendar year 18. And most enterprises will probably start off with POCs and start migrating and making more serious investments in the 19 timeframe from a coexisting transport for both SC, NVMe, as well as for Ethernet with RDMA and XFCE.
All right. Thank you. Tawfiq?
Okay, so in terms of specifically what applications, for the customers that we engage with, so of course we see the more traditional transactional databases, whether it's Oracle or MySQL, structured databases, but the predominant use model that we encounter is more in the real-time analytics space, whether it's in the financial sector or edge for telcos. In that case, it's obviously Hadoop, MapReduce, but increasingly Spark, because I think even though people tend to think of Spark as being dominated by memory, it's as per our measurements, we're finding out it's fairly storage sensitive too in terms of performance. So that seems to be a large amount of the traction that we see with our customer engagements is really around real-time analytics. So to answer the question on timing, as it turns out, with the scale-out analytics clusters, by and large, we're still buying SATA-based hard drives. That's sort of the momentum. So I think the time frame when you'd see the inflection point of adoption with NVMe over Fabrics is when the price per bit gets closer between NVMe SSDs versus, unfortunately, SATA hard drives, which is a really low target to hit. It doesn't have to match, but it has to be close enough for massive adoption in the real-time analytics space, which is where we see the most interest.
Yeah, I've been saying generally in the enterprise that it's when flash becomes 5 times the cost of capacity disks that the massive translation, that the massive transition occurs. So, Ahmed, what's your opinion on this?
Sorry, on mute. Okay, yeah, I like to view this in a slightly different way. If you look at flash storage today and the application when the flash storage is inside the server, it's fairly obvious. It's scalability of the number of applications and the number of cores you've got to be able to scale those applications effectively, whether you're running a database application, whether you're running some sort of a CRM or whatever the application class you're running. It's really about the efficiency of the NVMe OF interconnect to a storage subsystem that has multiple threads that are going to be running concurrently and giving that performance scale. So if you think of those applications that gain benefit of flash memory in the server, and then you look at that and say, when is those applications effective when the storage is disaggregated or centralized in some external storage array, the need for this low latency and the scalability of the number of concurrent operations you can do to a storage subsystem is where the benefits really come into. So if you ask me a general question, which applications are going to use it, I would agree with everybody else as what they've said. General analytics in the financial institutions that we work with is a lot of analytics capabilities on flash storage. Distributed is a big one that we see taking off. But in just general usage where there is data stored somewhere that needs to be accessed from multiple nodes on a distributed environment is a classic place where this will take. So I don't look at it in a specifically of a application, but all the class of application that needs to have block storage access that's distributed, that at the speed of NVMe OF or NVMe across fabrics is where we think the big movements are. But to be explicit, we have at least 4 POCs going on right now in all various sectors. In the financial institutions, we've got distributed storage, where I've just talked about previously, where they have diskless nodes that they want to implement using NVMe OF. So we think next year, a lot of POCs and early deployments of NVMe OF that will be starting, I think, early part of next year and then going into production and back end of next year.
Thanks, Ahmet. Elliot, what's happening at Broadcom?
Sure. So, I agree with a lot of the comments from the other panelists. I think the way we look at it as well is that there's, a lot of existing and evolving applications and workloads generated from those. whether you're looking at it from an enterprise or cloud perspective, and that there's a lot of similar drivers that are pushing for high performance storage, and that's beneficial for NVMe. And then it's the areas where you need that high performance storage across larger workload distributions, so the scalability is extremely important, and that's really where the Fabrics piece comes in. You know, in terms of the specific applications, again, you know, a lot of the panelists have already talked about it. You know, big data, financial analytics, media streaming, 4K video processing, editing. These are all things that we see, and that they all can benefit from you know, these scale-out type of environments. You know, on the cloud side, which is what we see, you know, maybe a bigger part of the growth really happening around the storage and disaggregation. There's both the bare metal and virtualized environment. So we see things like you know, classic VDI, database, KV store, map streaming. You know, I heard before, you know, the Apache Spark streaming, Kafka, where there's a transition from kind of the hard drive implementations to wanting to have some higher performance tiers in that storage. So we're seeing applications that are starting to look at, hey, how does NVMe fit into this, and how does Fabrics piece fit in? And then there's the upcoming stuff. There's machine learning. There's the IoT fog data analytics part. So there's a lot of moving pieces and that are evolving here. And I think all of those will be beneficial for NVMe and NVMe for Fabrics. You know, in terms of kind of deployment models today, you know, we're seeing it in different kinds of implementations. It's anywhere from centralized JBoss or what we call fabric-based BOS. And we have our solutions for both the initiator and the target side with our NetExtreme Stingray technologies that have been shipping out for a year and moving into deployment. And so we're seeing a lot of this activity. And so, yeah, we really do see, you know, as some of the other panelists were talking about, is, you know, a lot of POCs were happening this year, 2017, small deployments, 2018, and really a larger deployment where it hits a wider swath of the cloud-based and enterprise customers in the 19-20 timeframe.
Okay. Rob, Mellanox seeing about the same thing?
In some areas, yes, but in other areas, not. So we have partners in production today. We aren't just doing POCs. So, for example, NetApp at their Insight show 2 months ago announced the EF5700 all-flash array and the the 570 all-flash array and the 5700 hybrid, both supporting NVMe over Fabrics front side all the way to the, you know, between client and the storage subsystem. So there's production out there today. It's not just POCs. I think IBM just announced solutions at an event they had in New York City last week for their all-flash systems. So this is production in a lot of areas, especially with companies, shameless plug here, like ours, that are really leading this NVMe over Fabric effort. A couple of applications that I would add. One in the HPC space that's also in production today called burst buffers. Think Snap for HPC. So in HPC, you take a problem, divide it up among hundreds, thousands of computers, and what you will need to do to make sure that if one crashes, you don't have to start your whole simulation over is take what's called a burst buffer, or in storage words, a snapshot of where you are so you can restart. And NVMe over Fabrics is already being implemented on InfiniBand in that space. Couple of other areas that weren't mentioned. One that we have a couple of partners, E8 and Accelero, in production on is scale-out storage, where you take a bunch of commodity servers with NVMe drives in it and create a storage subsystem out of that clustered solution. And then hyperconverged, which is kind of the big brother of scale-out, where, you know, think Nutanix, where you combine the application and the storage on the same machine using virtualization. And again, E8 and Accelero in that space. And these are production solutions in the market today.
It's funny to me hearing you guys, well, before I pontificate a bit, let's move on to audience question number 2. Audience members, what are your primary concerns when deploying NVMe over Fabrics? feel free to choose more than one. We're storage guys. We're paranoid. We have lots of fears. So number one, we just don't need the performance in the near future. Number two, the cost. We're afraid NVMe over Fabrics is going to cost more than what we're currently buying. Number three, we just don't know what use cases it's good for. Fourth, the technology just isn't mature. Standards, interoperability, or the basic storage guy's excuse, I'm going to wait a couple of years and let somebody else make a mistake. NVMe over Fabric ecosystem immaturity, that there aren't enough arrays, switches, or management applications, or that they don't interoperate right. And of course, the always popular other. But as I was about to say before I introduce the question, I find it interesting hearing the applications that NVMe over Fabrics will first appear in, and hearing the same kind of things I heard a decade ago when I said, and where are we going to see Flash first appear? Well, it's, analytics. We're going to see it in analytics. People will buy a violin and stick it in there. It's also a difficult question to answer because NVMe over Fabrics offers so many different deployment models. On the one hand, we can set up a JBOF and slice off pieces of those SSDs and allocate them permanently to hosts, which will view them as if they were local non-shared SSDs for caches or scratch space or some other use that doesn't require shared access. Then we have the guys who live natively in the cloud who don't need multipathing and the other features we haven't quite built in yet to NVMe for the Fabric because they handle resiliency at the application level. And if you're Google or Facebook, you can write code around the protocol not being quite mature enough for you. And then there's replacements for what we now call disk arrays and for the back end of what we now call disk arrays, the JBOF. So there's so many different deployment models. I think users are going to find applications. And of course, the users who find those applications first are the users who are least paranoid and most in pain. And that means HPC and analytics and the places where you can turn fast into money quicker. So moving right along, we've recently heard, and I first heard of it at the Flash Memory Summit this summer, of NVMe over TCP. How do you expect TCP utilization and implementation to be different? And this is, both technically and in terms of customer deployments from the RDMA or the fiber channel NVMe over Fabric transports. And Amit, this is right in your wheelhouse, so why don't you start us off?
Yeah, so I want to start from the latter part of the question, which is what are the use cases where TCP tends to be predominant and where we see it picking up real strong pace. The area that I think it's most important that we've identified is in the customers, these are real end users who are trying to deploy, are starting to say, okay, I'm moving away from the traditional non-scale-out infrastructure to a more modern scale-out infrastructure. I'm moving away from the traditional SANs. How do I implement something that will benefit me in terms of disaggregated storage? And the first question that we've seen and first problem that we've seen in the industry, which really got us going into this space, was the fact that there is a different replacement for fiber channel or traditional iSCSI SANs with a new protocol type that runs on top of Ethernet called RDMA. And a lot of our customers, when we first engaged at that level, were finding it difficult to then add another layer of protocol on top of their existing infrastructure of Ethernet. And so this new protocol created a lot of barriers and problems of deployment, use. And it's not about how good the protocol is or how technically viable. It's actually adding a new layer of protocol that they have to manage and utilize and effectively implement. We approach this by saying, well, what would it be not possible to do this on top of standard TCP/IP, as they know and they love and they use and they're very effective at today? We know clearly that the bandwidth performance is not an issue from a technical perspective, because you've got the speeds and feeds as normally you would have in typical SANs, even in fiber channel based environments. But you also are very little gap between running RoCE or IWARP encapsulated on top of TCP/IP protocols, whether it's UDP or TCP. Why not go directly to TCP? And could you implement a solution that's good enough and effective enough in terms of performance? That's where we saw the motivation for us to go enter into this space. Clearly, having a protocol or a network device like a NIC that has low latency profiles is important for these sort of solutions. But at the end of the day, the question was, how big is the gap technically of implementing the same level of performance versus the traditional approach of RDMA on top of TCP or Ethernet? And so we looked at it, and our initial results showed us that there was very little gap between the two. And what this allowed us to do is go into customers and say, okay, if we allowed you to use this protocol on top, just as on your standard Ethernet layer 2 switches and infrastructure that you have, where you don't have to worry about routing and capabilities, would that be something that would be interesting for us? So that's the motivation and direction why we went down the path. It's all about ease of deployment, not adding a new layer of complications on top of their existing infrastructure, their network infrastructure. That's what started us off. And that's where we think is the value of TCP over NVMe, NVMe over TCP.
Okay, I've got one follow-up question. NVMe over RoCE or NVMe over IWARP requires a NIC that supports RoCE or IWARP. Would NVMe over TCP run on any arbitrary NIC, or is there still a hardware component where we have to do offloads?
No. In fact, the plugin that we've used in our current POCs and also contributing to the NVMe.org does not require any specific NIC. It actually works on anybody's NIC. And in fact, all the benchmarks we did initially will run on the Mellanox NICs as is.
Okay. So Rob, what do you have to say to that?
Well, we think that it's very complementary. NVMe over TCP is very complementary to RDMA solutions. It's basically all about performance. Today, there's many examples of IP solutions for applications that, for reasons like legacy network support or stranded servers or geographic distance spanning needs, have IP configuration options. Microsoft Spaces would be one example. You can run it in either RDMA mode or IP mode. In fact, it can automatically switch between the two. And the difference is, of course, the performance. At Microsoft Ignite a couple years ago, they did a demo, an on-stage demo. I believe there's a YouTube of it. I know there was. Assuming it's still there, you can do a search for it and watch it. And they actually switched between RoCE, RDMA over Ethernet, and IP modes on the fly, in front of the audience. And with RoCE, the performance was twice the IP performance and half the CPU load. And this is pretty much what we see. This is pretty typical. There's an RDMA version of iSCSI called ICER, and it's about the same match. And the testing that we've done with NVMe over TCP, we're seeing, performance differences, similar performance differences. But it's an immature, spec. It isn't done yet, so you can't, say what it's going to end up in the end. But for Mellanox, it's purely a customer performance choice. Our adapters and switches, as was noted by the last question answer, support both, and there's no price difference. So we see it as very complementary. It's just all about performance that you want.
Okay. Elliot, do you have anything to add to that? Elliot, if you're talking, you're muted.
Oh, sorry about that. Yeah, I think from our perspective, it's really a customer choice, a preference. So whether they require the high performance and low latency of NVMe over RDMA or Rocky, or it's more of a scale. So they've got geographic distances of metro scale kind of requirements, and they prefer TCP. It's ubiquitously deployed today. It's resilient and robust. We just know that there are some folks who are, more inclined to want to leverage their TCP infrastructure. And so what we feel is most important is having an extremely flexible architecture to be able to support that. From our RDMA-based NICs or standard NIC technology to our NetExtreme Stingray SoC, having that software-defined capability, we can support both. As a matter of fact, we're working with a partner right now, and we've already been able to demonstrate concurrent operation of NVMe over TCP and NVMe over Rocky at the same time. And we'll be disclosing more about this early next year. But from our perspective, again, it's really it's a customer choice.
Okay. Tafiq, anything to add?
Yeah, so probably just emphasizing what people have already said. It depends on what environment the customer is trying to deploy an NVMe solution into. So if it's across a lossy network, then even though we're making the Rocky V2 implementations better, we're dealing with drop packets, inevitably people still tend to think of TCP as a preferred solution for lossy networks. But you can't have your cake and eat it too. If you're designing for a high performance application, then it really should be a well-designed network with minimal to no packet loss. So if that's the case, if you're really designing for high performance, then that's where NVMe over Rocky would make sense. So to that regard, maybe I'm just agreeing with what folks said earlier. It depends on the deployment environment. If you want high performance, it should be RDMA. If you have to live within a lossy network, then that's where NVMe over TCP comes in.
Okay, it seems like we're coming to a consensus that while NVMe over TCP might not be the ultimate performance solution, it's still going to be 3 to 4 times faster than running SCSI, and therefore might be a good solution for people who have other reasons to want to run TCP. Does that sound right to you, Brian?
It does. I think we're all in violent agreement here. So we here at Chasm Networks are embracing this, participating in the formation of the new standard. We think it's a great and complementary option to RDMA. It's there are a lot of data centers out there that are layer 2 in nature or are generally anti-RDMA. I'm sure everyone can guess who we're talking about here. This TCP as a transport is going to be great for entry-level applications, as we mentioned. I agree with Taufik that where you don't need full-blown performance and you don't want to have to stick a specialized NIC into your compute server, then this will work. It's not going to be as fast because you've then by definition lost the OS bypass benefits of RDMA on the host side. But if you can get into a generally lossless environment, and as Taufik said, again, architecting the network appropriately, we see this in this case that the target side performance can be essentially equivalent to that of an RDMA-based environment. TCP does not necessarily mean you have to have a driver running TCP. It can be done in hardware. It can be done very effectively in hardware. We've seen this numerous times over the history of TCP.
Those of us who lived through the iSCSI wars are well aware that the overhead of TCP can be exaggerated by people who want to sell something against it.
Yeah, so I'd like to say, sorry to disturb this discussion, but I believe the delta between a Rocky or an iWarp implementation versus TCP is being over-positioned. I think if you have a well-balanced network that is connected in your infrastructure, the deltas we're seeing without our NICs are very minimal, within 10% of each other. So I'm not sure the jury's, I believe, is out for this. Yeah, TCP is always going to be a laggard behind it. I think it's very close. I think the real problem is actually what was just mentioned earlier on, kernel bypass, which the RoCE implementation of NVMe over TCP does not do kernel bypass. Let's make sure that fact is on the table. But doing real kernel bypass inside the operating system has an opportunity both for RoCE and TCP to be significantly faster.
So would it be fair to say, we're talking about the difference between a top fuel dragster and a funny car, not between a top fuel dragster and your Prius?
I wouldn't get that. Yeah, that's close enough. I'm going to agree with that one.
Okay.
I think what you have to understand, though, is that everything is going to move forward, right? So what we're hearing about performance different and what we're seeing about performance differences on TCP, NVMe over TCP, there's also a lot of updates coming for NVMe over Fabric on RDMA. So I think the performance difference is going to be maintained at least, north of 20%. Also, the RDMA NICs.
As a guy who runs a test lab, as a guy who runs a test lab, we'll see.
RDMA NICs are also, it's pretty much standard on NICs now, so it isn't like you need a special NIC for RDMA.
Although I have seen that most NIC vendors are choosing to be either in the RoCE or the iWarp camp and not both. And so that may still lead to some, I need to buy a NIC to connect to the storage system because the one in the LOM doesn't do the version of RDMA that I need.
Well, thank you, everybody. We've got a few questions from our group here. I'm going to ask Howard the questions, and Howard, you can farm these out to the panel as necessary. The first question is, does RoCE use UDP as a transport? If yes, how is data integrity addressed?
Oh, why don't we let Rob answer that?
Great. So the answer is correct, and the data integrity is maintained by the RoCE protocol.
So
in
it's,
essence,
it's just at a higher level in the stack.
Correct.
Excellent. Second question, do you just expect to see NVMe over Fabric being deployed with the higher end storage arrays, or do you expect it in lower end arrays also?
Oh, I'll take that one myself. I expect NVMe over the next decade to essentially replace SCSI. And so that would mean that we'll see NVMe over Fabrics on the back end across the board. The death of iSCSI or Fiber Channel or NFS or SMB or S3 is vastly overstated. That as access protocols, those will be around a long time, but the back-end protocol will go NVMe over Fabrics, I think, relatively quickly.
Let me, this is Taufik, let me volunteer an answer as well. So there's a whole spectrum of possible implementations. So at the far left, you can think of a simple NVMe over Fabric JBOF as being a glorified SAS replacement for a SAS JBOD, exactly to Howard's point. So there could be very low implementations. So I expect there'll be a whole spectrum of solutions at different price points.
Excellent. Thank you, guys. Last question. It's a two-parter. The first one is actually addressed to Amit. To the Solar Flare presenter, you talked about NVMe over TCP, but finished with NVMe over layer 2, parentheses Ethernet. Do you want to address that?
Sure. Yeah. So our first implementation of NVMe is over TCP/IP. So it is on TCP/IP.
And I think the comment that the questioner was asking about was, Amit referred to layer 2 data centers. And that's, would be really IP as layer 2 and more as, and we don't route, than a comment about whether it runs in TCP/IP or on bare metal.
Thank you. That's correct.
And then the second part of the question was notes. DC data center, I assume that means equals TCP.
That's not
vanilla
equals.
TCP. Oh, not equals vanilla TCP, since with NVMe storage is finally faster, the networking and cast issues might get to a completely different level of magnitude. You want to hit that one, Howard?
I'm not completely sure what he means by NVMe storage is finally faster than networking. Certainly, at what will soon be the typical 24 SSD JBOF in terms of bandwidth can saturate multiple 100 gig Ethernet channels relatively quickly. In terms of latency, SSDs are still at least on the same order of magnitude, if not somewhat slower than the transport between two devices on the same top of rack switch. Certainly, traffic management will remain an issue in the network world, but that's what it always has been.
Thank you. And everybody, thanks for attending our webinar hosted by G2M Research and Deep Storage. Thank you for our panelists. I hope everybody found this interesting. We will send to everybody who registered for the event the links to the live or to the recorded version of the webinar as well as the slides. And if you have any more questions, feel free to send them to info@g2minc.com. Thanks, everybody, and have a great day.
Thanks, Mike.
Thank you.
Thanks, guys.